Okay, good morning everybody. Sorry I'm not there. I have a doctor's appointment once a year. My doctor needs to see me and check out my heart and my health. So that's where I'm at, is when I'm actually getting checked over. So I'll be here tomorrow. So we have a test tomorrow, but you can do this. This is your review. Okay, I'm going to do part of it, and you guys can do the other part as homework, and you can use this on your test. So make sure you do it, okay? So let's do this, okay? Hopefully you have the sheet in front of you. And if I get going too fast, please ask the substitute to pause it to let you catch up, okay? All right, so number one, tell whether it's direct variation, inverse variation, or neither. So direct variation, let's write this down. Direct is some y equals some mx plus 0, okay? Has to go through 0. M is like a slope. The book likes to call it k, constant of variation, okay? Inverse variation is going to look like this, either x times y equals some number, or you could solve for y, or you could have y is equal to some k divided by x, okay? We know that the graphs of these look something like this. Direct variation, the graph looks straight. It's a straight, nice straight line going through the origin. And we know the inverse variations, they look like this. They look, when one gets big, the other gets small, and vice versa, okay? All right, that's what the graphs look like. We've done this before, okay? So number one, xy equals 24. Yeah, definitely. It's going to be inverse, okay? Number two, 3/4 plus 3. Probably neither. Okay, this one was inverse. Inverse. Okay. xy fits that perfectly. xy equals some number 24, okay? What times what makes 24? 2. It's that plus 3, see? It's supposed to go through the origin. That one's going to go 3, so that's neither. And number 3, 1/2 x plus, there is a plus 0. It'd be a straight line. It's got to be direct. Okay? All right. Number 4. 1, 2, 3, 4, 2, 4, 8, 16. Looks exponential. Looks exponential, which is neither. Exponential, which is going to be neither. Okay. 5, though. 1 times 8. That's negative 8. 2 times negative 4, that's negative 8. 4 times 2, that's negative 8. And 8 times negative 1, that's negative 8. So it looks like x times y equals some number. X times y equals some number. The number is negative 8. So I'm going to call that one definitely inverse variation. Okay. Now again, I'm not going to do all of these. I want to do some of these, but I'm going to let you guys finish it up. But let's do 6 for sure, and I'll do some of these, and I'll do some of these. Okay. All right. So let's see. X and y vary inversely. All right. So x times y equals some number. Okay, it's that one right there. I know when x is 5 and y is negative 3, we get our value k. K's got to be 15. Negative 15. Okay, so I have an equation. I've got an x times y equals negative 15. All right, great. There's my equation. It says write the equation. I got part 1 done. That was easy. Just that times that. I got the value of k. I rewrote it in its formula. X times y equals some constant. I got it. Boom. Got the first equation. Now the second part is find y when x is negative 4. So let's use our equation. Let's put negative 4 in for my x. I'm going to rewrite this as, well, x, which is negative 4. Replace x with negative 4 times y equals negative 15. And solve. Divide by negative 4. Divide by negative 4. What's that? 7 halves, 3.5. I think that's 3.5 for y. Okay? All right. I'll give you a second. I am going to do some of these on a separate sheet of paper because I don't think they're going to fit. So I'm not going to do them all. 7, I'll set 7 up and I'll let you guys finish it up. It says simplify, so I'm going to factor. On number 7, I'll factor out an x from the numerator. And I'm going to ask you what times what makes 25? 5 and 5. X plus 5, x plus 5, Cancel, cancel, right? 8, you're just going to cancel, 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 cancel. Y's with y's, x's with x's, just cancel, cancel, cancel until you get it simplified, okay? You can do that. Cancel, cancel, cancel. 9. To do 9, we're just going to factor, cancel, cancel, cancel. I'll take out a 2x. I'll have an x plus 1. I'll common factor out an x minus 3. I'll factor x squared minus x minus 6. I'll get an x minus 3, x plus 2. And I'll factor this one, x plus 1, x plus 1. You guys can finish this, okay? I don't want to do them all for you, okay? 10, you've got to flip the second fraction. And then it's going to be like 8, where you cancel, 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 cancel. So you've got your 5x squared, or 7y squared times 35y cubed, over 15x squared, and right, cancel, 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 right? You guys know how to do this, cancel, cancel, cancel. But I want you to do this, not me. I'm just setting you up so you guys can do this, okay? 11, you're going to flip it, and then factor, and you're going to do it just like you did 9. You're going to factor, don't forget to flip, and then you're going to factor it, and then cancel, 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 cancel. 12 and 13, we're going to add. 12, 13, 14, we're going to add. You already have a common denominator, so you're just going to go straight to your common denominator and go x minus x, which cancels out. And then negative 9, subtract 9. That's going to be a negative 12, okay? Make sure you see negative 3, subtract 9. That's a big mistake on the test. Don't forget to do the negative to the 9, okay? Oops, I got the 1. 13, same thing. You've got a common denominator, which is already x plus 2. When you add 6x plus 12, okay, this one's not done. Not done. Make sure you factor out the 6 and see what happens, okay? Okay, again, I don't want to do all of this. I want to give you guys time to work on this and finish this up, okay? 14, I'm going to first factor for a common denominator. I'm going to factor out only the bottom, only the denominator, x plus 2, x plus 3. Now, we need a common denominator. Again, if I get going too fast, I'm trying to get this done, but if I get this going too fast, just ask the substitute to pause it. I need to get to the doctor, so if it's too fast. Okay, so I'm going to multiply this one by x plus 2 over x plus 2. So I know what my common denominator is. My x plus 3 times my x plus 2. And then you're going to simplify the top. The numerator x squared plus 2x minus a 1x minus a 2. And this one might factor. It might factor and cancel, okay? I'll let you work on that. All right, I'm going to turn the page in a second. And again, if you need the substitute to pause it, they can, okay? All right, now, number 15, we're going to solve. Okay, that's what we did on Friday. I'm going to cross multiply. I'll get a fraction equal to a fraction. I'm going to cross multiply that one times that one times that one. I'll get a negative 1 equals x times x plus 2. I'm going to distribute. I will maybe have to factor. Okay, so maybe I'll have to factor. I'll get a negative 1 equals x squared plus 2x. I'll bring over the 1, x squared plus 2x plus 1 equals 0. Factor and solve, okay? All right, 16. 16. To do 16, oh, we could just take this one and bring it over here. Wouldn't that be easier? Remember we learned that trick Friday? We're like, wait a minute, there's an easier way to do this one. So if I rewrite it, x over 3 equals a 4 over an x plus 2. Now to bring this over, it says negative. To bring it over, I'm going to add it. I'm going to add the whole thing because I see a common denominator. Add it. So go plus my 2x over my x plus 2. I'll have a common denominator. x plus 2. Then I'll have a 4 plus 2x. And then cross, multiply. You might have to factor and solve, okay? You can do that. I know you can. I know you can do that, okay? All right, 17, we're going to graph this. And before I graph it, I need to know what my domain is. So I'm going to factor my numerator. I'm going to have an x plus 5. I'm going to have an x minus 2. Here's what I know. X cannot equal negative 5, right? If x is negative 5 plus 5 is 0, and x cannot equal 2, because 2 minus 2 is 0. Cannot divide by 0. So the domain is going to be x equals all real numbers, everything. X can equal everything, all real numbers. It can equal everything except x cannot equal negative 5 or 2. Right? Now, the asymptote is at 2, because that one's, you can't cancel that out, okay? So my vertical asymptote is at x equals 2. My whole is at the one I can't get rid of, which is x equaled negative 5, okay? So when I graph this, I know my graph has to look like this, okay? And I don't have to do a perfect job. I don't even need Desmos for this, because I know a couple of things. I know I'm going to have an asymptote at 2. Okay? So I know my asymptote goes right there. Let me draw my asymptote. 2 has to be 2, because you can't divide by 2. And I've got a whole at negative 5. But I know the graph has to look like this. Remember? It has to look like this. Okay, it's going to look something like this. Something like this, okay? And I'm going to have a whole at negative 5. At 1, 2, 3, 4, 5. So I have a hole there. You can't see it. Anyway, that's all I need from you for the graph, okay? But I definitely need the domain for sure, okay? Now, last but not least, a little story problem. They're not that hard. Beth can tile a floor in 10 hours by herself. But if she works with Tom, they can tile a floor together in 5.8 hours, okay? So this is how we're going to do it. So we're going to make a chart. This is a work problem, okay? Make a chart. Beth and Tom, okay? So Beth can do the job. She can do the one job in 10 hours. Tom, we don't know. He can do the one job in X hours. We have no idea, right? But together, they can do it in 5.8 hours. So what I'm going to do is set this equal to one job, and I'm going to multiply this by my 5.8. Okay, this is how it works. So Beth can do 10 hours. She can do 5.8 parts of the job. So we're going to change this to 5.8 over 10. Tom, we don't know, but he can do his part of the 5.8, his ratio of the 5.8 in X amount of hours to get the one job done. Okay, so here's how it works. So now what I want to do is solve for this. Well, the easiest way to solve for this, first get a common denominator between these two, okay? All right, and I'll go over this again with you guys tomorrow before you take the test, okay? So common denominator, x over x, common denominator, 10 over 10, and I'm going to get a 5.8 x over 10x plus, if I multiply 10 times 5.1, I get a 58 over 10x equals 1. All right. Now, let's multiply. Let's solve for x. I'm going to multiply by 10x. Just multiply that up. Multiply, it's like cross multiply, right? I'll squeeze that up here. I'll take that all the way up here, okay? I'll have a 5.8x plus 58 equals 10x. Solving for x is easy now. Minus 5.8x minus 5.8x, 58 is equal to, I don't know, well, yeah, I do, 4.2, right? I can do that in my head. 4.2x divide by 4.2, divide by 4.2x equals, I don't know, calculator, 58 divided by 4.2, and I get an answer about 13.8. Okay, now, what do we find? Okay, let me go back through this. Okay, write that down. Let's figure out what I got. Okay, so here's the thing. Together, they can do it in 5.8 hours. If they work together, if Beth does it by herself, 10 hours. If Tom does it by himself, 13.8 hours. But together, they can do it 5.8, okay? So, Beth's portion of the work plus Tom's portion of the hour takes them 5.8 hours together to get 1. It has to be equal to 1 to get one job. So I multiplied by the 5.8 because that was what their portion of the job was. Okay, but then to solve this problem, I needed a common denominator, which would be 10x. Multiply this by x over x. Common denominator 10x, 10 over 10. And then I have my common denominator, 5.8x plus, well, that's 58 equals 1. Multiplied to solve, I got to solve. Multiply by 10x, solve minus 5.8x, minus 5.8x, 58 equals 4.2x. Solve by dividing, 13.8. What's that? That's Tom's portion of the work by himself, okay? Now, I'll be here tomorrow. We can work on this together. What I want you to do is finish this up, okay? I want you to finish this up, and then I want you to work on your towers, because our towers are going to be due. We're going to squish them on Wednesday the 15th, okay?